So algebra matrices. And so here we just got done working with all this other stuff of, yes, there has to be some magic matching and all this stuff. And so here, working with matrices breaks a lot of the little rules of what you used to be able to do with numbers and constants. Matrices have their own set of things. Now, why do we use matrices? Well, there's a lot of data collection. We're going in from the information age to the data age, and so we're just collecting data on everything, especially some of the major tech players do it. Not all of them, some of them are trying to protect their data, thankfully. But, you know, but take Netflix, for example, right? Netflix wants to say, well, what should you watch next, right? And one of the ways they do it is what they call sparse matrix. And so they have these huge matrices of all the movies and how well you've rated them, right? And then they use these matrices to predict what you would like to watch later based off of who else watched what else, right? When they watch the same thing you've watched, right? They're using data to help you to stay on their platform. As long as you're on the platform, the more money they make. And so this is how they use that sort of stuff. You know, machine learning, that's data, that's matrices. What's behind that are matrices. How to solve large systems of equations, that's matrices. Simulating electromagnetic waves in a computer, that's matrices, right? And so you just have to be, as an engineer, you're going to encounter matrices. And so we've kind of used it to solve linear equations. Now we're just going to show you how to use basic algebra with this. And the basic thing we need to say is one or two matrices equal. So let's start there. Two matrices are equal if their entries match entry by entry and they have the same dimension. And so let me show you a couple of example of things that are. So here, if I say it's 1, 2, -7, and 6, so this is a 2 by 2 matrix. That has to be equal to a 2 by 2 matrix, which is, now let's do something. Let's just do 3, 4, 5, 6. Okay, so here's a 3 by 2 matrix. So 3 rows by 2 columns. So we say a 3 by 2 matrix. And here, notice that the entries have to be equal, but they don't have to look the same. So I could have the square root of 1. Well, square root of 1 is 1. I could have 2. Well, 2 is 2. Here I have 3. Here I could have 2 squared. Well, that's 4, right? I could have 10 divided by 2. Well, that's 5. And then I could have 2 times 3. And that's 6. And so what goes in the little entries does not necessarily have to be a constant. I can have operations and all this other stuff can go in there. But as long as this equals this, this equals this, this equals this. And notice this is a 3 by 2 matrix. This is a 3 by 2 matrix, and they have the same dimension. Okay? Where it's 3 rows and 2 columns. So what are non-equal matrices? So here, if I have the 1, 2, 3, 4 matrix, well, that doesn't equal the matrix of 1, 2, 3, 4, 0, 0. And you're thinking to yourself, well, hey, there's nothing here, so why can't 0 be equal to nothing, right? And it makes good sense. But for the sake of this class, we're going to say these are unequal matrices. Are there math classes where you might say these are equal? Well, you won't say they're equal, but you say the isomorphic projection of this into this space, then they're equal. But that's pretty fancy for this class, so we're not going to worry about it. So they have to be the same size. If not, they're just not equal to each other. 2, 1, 4, 3. So let's pretend, and they also have to be in the same. So here, these are not equal, right? Even though I have a 1 and a 1 here, and a 2 and a 2 here, and a 3 and a 3 here, and a 4 and a 4 here, they're not in the same spot. So here, the 4 has to match the 4. So this 4 and the 3. So these are not equal matrices. So in order to be equal, they have to be in the same position, at the same spot, at the same time, okay? Then at the same size. And so there's a lot more constraints. All right, so sum, difference, and multiplication. Right, so let's talk about this. So let A be a matrix. And so this is how you say let A be a matrix. You just put a little bracket, say Aij, of the same dimension. So A and B are some matrices of the same size. Sums are done entry by entry. So if I let A plus B, that means I just add them up entry by entry. Differences are done entry by entry. Scalar multiplication. So if we have just a single constant, we call that a scalar for the sake of matrices. You call it scalars other places. Scalars are not a matrix. There is a difference between 3 and the matrix. These are not equal. And this is the scalar 3. This is the 1 by 1 matrix with the entry 3. These are not the same. Okay. And so this is a scalar. And this is a matrix. Okay, so just be careful about that. Now, are there going to be places in some math classes where you can do this sort of thing? Yeah, but then they do the isomorphic projection into a 1 by 1 matrix. Once again, don't worry about it for the scale of this class. Just say this is a scalar, this is a matrix, they're not the same. But if you have a scalar and you multiply it by a matrix, you just multiply each entry by that. All right, so let's actually do this. And we're going to do it here on this page. All right, so here we have a bunch of stuff to do. Okay, so here I'll give you a bunch of matrices. All right, so let's go ahead and start doing this. So we're going to add A and C. And so I'm going to write this out. Yeah, we got plenty of time to write it all out. So here we have 1, 0, 0, 3, negative 2, 6. So this is my A, right? And I'm going to add to it C. And C is over here. And I'm going to bring it close together just for the sake of A, teaching, but B, of ease of doing the arithmetic. Minus 1, 9. 3 and -3. Right, so now, if we're going to add these up, do they have the same size? Yeah, these are both 3 by 2s, right? So they're the same size. So I can do this. So we're just going to do it entry by entry. So here we're going to just, let me just show you what I'm going to do before I do it. I'm going to take this and I'm going to add this entry to this entry to get this one. I'm going to add this entry to this entry to get this one. Okay, and then so forth. And so let's actually do that. So 1 plus 2 is 3. 0 plus -1 is -1. 2 plus 3 is 1. 0 plus 3 is 3. 3 plus 9 is 12. And then 6 plus a -3 is 3. Okay, so you just do it entry by entry. So let's add A and B. So let's add these two together. So here I have 1, 0, 0, 3, -2, 6. That's my A. We're going to add to that B. And here I have 1, -1, 2, 3. Close that there. Let me clean that up. All right, so if I was going to do this here, let's go ahead and grab this again. I grab this entry plus this entry will give me this entry. This entry plus this entry will give me this entry, right? But this entry, oops, I didn't grab the color I wanted. This entry plus, right? And so there's nothing here, right? There's nothing here. And so this is what we're just going to say is not equal to anything. It's equal to undefined, right? It's undefined. So they have to be the same size. So they have to be the same size. Have to be the same size. So in order to add them up, you have to be the same size. All right, so let's do B minus D. And so let's do that. So be 1, -1, 2, 3. So that's my B. We're going to minus that out from D. So it'll be 3, 0, minus 4, 4. These are the same size, so I can proceed with my operation. We're just going to go unit by unit. 1 minus 3 is -2. 2 minus a negative 4 would be adding 4, so that becomes 6. Negative 1 minus a 0 is still negative 1. And then 1 minus 4 is, or 3 minus 4 is, of course, negative 1. Okay. So here, we can do this. So let's go ahead and do this one. So let's do this. And so here we're going to do 2a. So 2 times a. So a is 1, 0, 0, 3, negative 2, 6. All right, so let's just crunch through this. And so if you have 2 times this, you're just going to multiply it 2 times this, 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 and 2 times this. So just entry by entry. So this is 2, 0, 0, 6, 2 times this, negative 4, and then 12. Okay. All right, so let's do these two. All right, so let's do 2b minus 3c. Now let's just look up real quick. Can I do 2b minus 3c? Can I do this? I'm just writing chat, yay or nay. No. I can't because they're not the same size, right? So this is undefined. And it's because they're not the same size, not the same size. Not the same size, or a better word probably for it is dimension. Just right size. I can write the word dimension. That's close enough, you know what I mean. Not the same dimension. So the dimensions of the matrix, or the size, I use them interchangeably. I think dimensions is a little bit more precise. All right, so let's do this one. So 2a minus 3c. Well, 2a I can do. 2a minus 3c. Since these are the same size, that's fine. We'll just have to multiply by the scalars. So I know what 2a is. Yeah, I already calculated it. So let's just put that down. So that's 2, 0, 0, 6. Make my 6's and 0's be a little bit more distinct before I get my butt in trouble. Minus 3 times c. So 3 times c would be, in this case, it would be 6, 9, minus 3, 27, 9, and minus 9. So I'm just multiplying 3 here gives me 6, and 3 here gives me negative 3, 3 here gives me 9, 3 here gives me 9, 27, and then negative 9. And I'll zoom on in so my handwriting's a little bit better. All right, so here we're just going to go entry by entry. So 2 minus 6 is negative 4. 0 minus 9 is minus 9. 0 minus negative 3 is positive 3. 6 minus 27 is minus 21. Negative 4 minus 9 is negative 13. And then negative 12 minus and minus 9 would be plus 9, so it'll be 21. Okay. Specifying it makes it just one. Yeah, so there's an undefined matrix is the matrix itself is undefined, but there's no operation. I have no definition. So when I write undefined in math, what does that mean? That means that according to my rules of mathematics, when I perform this operation, it can't be performed, right? It's kind of like 5 divided by 0, right? That's undefined, right? And that means this is not well defined. I don't know how to divide by 0, right? It's kind of like I don't know how to add these matrices if they're not of the same dimension. We just say it's undefined. Now, people will make definitions in order how to do stuff like this or stuff like this. by saying just take the isomorphic projection and blah, 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 blah. And our way, up until you hit really high mathematics where you start, messing with the rules a little bit, and you have to do that very carefully and very safely. Undefined means it just doesn't exist right now. Whatever that is, we haven't defined it, it doesn't exist. And so in math, if something's not defined, it doesn't exist. It's kind of terrible, right? Just how we operate. All right, so let's go ahead and do multiplication. All right, so here we go. So here, matrix multiplication. So let A be a matrix and B be a matrix where the dimension of A is m by n and the dimension of B is n by k. Then C has of dimensions m and k. And then the Cith entry is A, it's AI1 times B1j plus AI2 plus B2j. Now this is really kind of confusing. What does it really mean? Does it mean just translate it into more basic English for you guys? Multiply the ith row by the jth column, entry by entry, and then end on. Okay, and this is just something easier seen than done. Easier shown than explained, right? It's kind of easy. Let's say this is a good way. Let's do something easier shown than explained. Actually, there's some things you can easily show that are terrible to explain. But I won't get it. I'll maybe tell you a little something like that later. It's kind of like if you had a picture of your friend, right? One of your best friends, right? And let's say you're trying to describe your best friend to someone, and they go into a huge convention to go find your friend. That's really hard to explain what your friend looks like. But if you just show them a picture, right, and send them in, there's a lot better chance they'll get it correct. So there's some things that are just easier to show than explain. And so this is one of those cases. So let's just go ahead and do this. So here I have the same matrices. I didn't change them. But now we're going to do multiplication and stuff. So let's do this. So here we're going to do A times B. So here I have A 0, 0, 3, minus 2, 6. I'm going to multiply that by B. Now, if we were adding or subtracting, we could not do this. But multiplication, we actually can. Why? Because what do we need to have here? So let me show you what we have. This is a 3 by 2 matrix. This is a 2 by 2 matrix, right? What needs to match in the middle is it has to have the same this. And so if these two match, so if the two inner ones, if these match, right, just a little bit, if these match, then you're okay to do the multiplication, right? You're okay to do the multiplication. So if your first one has the same number of columns as this one has rows, you're good to go. Go ahead. The resulting matrix will be what these two are. And so this is going to equal sum 3 by 2. Okay. All right. Notice here, let's do B times C. Here, if I did B times C, before we even do the multiplication, I'm going to show you that this one doesn't work. This is 2 times C. -1, 9, 3, minus 3. I'm going to go ahead and write that kind of small real quick. So this is a 2 by 2. This is a 3 by 2. These don't match. So these don't match. So the number of rows does not equal, or the number of columns in this doesn't equal the number of rows. So this one is undefined. Okay. This is undefined. Here, notice that if we did A times C, this is 3 times 2, this is 3 times 2. This doesn't match, or C times A, that doesn't match. So that'd also be undefined, even though they're the same size, right? These are the same size. Since these don't match, since the rows don't match the columns, it's undefined. And so what I wanted to show here is that here, while these don't match, a times a 3 by 2 times a 2 by 2, I can do this. A 2 by 2 by a 3 by 2, I cannot, right? And here, even if I do a 3 by 2 by a 3 by 2, once again, I cannot do this. All right, so let's do this. Yeah, I only got 6 minutes. So let me see if I can do this in a way that will make the most sense. So let me go ahead and grab this in red. All right, so what I'm going to do is I'm going to take this row, multiply by this column. Okay. And so here would be 1 times 1, which is 1. Let me write that out. Actually, I'll write out. Let me write out 2 of them. Let me write out 2 of them. So this is 1 times 1 plus 0 times 2. So that indeed is 1. Okay. And let's go ahead and grab this box right here. And so this is going to be the second row by the second column. And so this will be 0 times negative 1. There we go. That works. Plus 3 times 3. So 3 times 3. And that will be 9. Okay. I'll do one more. Let's do this one. This will be the third column by the first row. And so it's our third row by the first column. So and we'll do this real quick. So this would be negative 2 times 1 plus 6 times 2. And that will give me minus 2 plus, so that gives me 12. Okay. And what I usually do is I kind of use my fingers and I'll just kind of go across and go down. So here for this one right here, I'm going to be going, this will be the first row and the second column. So 1 times negative 1 and then 0 times 3. So that's negative 1. Here for this one, it'll be 0 times 1 and then negative 3 times 2. So that's 6. And then for this one, it'll be the third row times the third column. So negative 2 times negative 1 would be negative or be positive. I'm going to write it out. Do some brown. So we have negative 2 times negative 1 plus 6 times 3. So that's 18 plus 2, so that's 20. Okay. This just takes a lot of, you just have to do this a couple times before it becomes second nature. All right. So now, just for the sake of time, I'm going to write down what these answers are and explain a couple things. All right, so here, if I did this math, I'm going to get this. I'll get 7 minus 4 minus 6 and 12. And this one, I will go ahead and crunch some of those numbers for you, just so you know what I'm doing. So here, these are 2 by 2s by 2 by 2s, so I'm allowed to do this, and the resulting matrix will be a 2 by 2. So here, I'll just run through how to do this. So it'll be 3 times 1, 0 times 2. So 3 times 1 is 3 plus 0 times 2, so this is just 3. For the next one, it'll be 3 times negative 1 plus 0 times this, so this will be minus 3. It'll be 4 times 1 plus, or negative 4 times 1, so negative 4 plus 8. So that gives us a positive 4. And here I'll have negative 4 times 4 plus 4 times 3, so I'll give us 16. Okay. And what should we notice here? Here I have the matrix B times D. That gives me this result. Here I get D times V. That gives me this result. These two matrices are not the same, right? They're not the same. They're not equal, right? And so multiplication is not commutative. That means you can't switch A times B does not equal B times A in general. Okay? It's just not. And so you no longer have the commutative property of multiplication. All right. Well, that's the end of the lecture and the end of class. I'll let you guys copy that down. Matrix multiplication just takes a couple times to do it. I'll show you how to type one in Wolfram Alpha just real quick. So if you need to go, go. But if you want to see how to type one in Wolfram Alpha, I'll show you how to do that. So if I wanted to write matrix multiplication in Wolfram Alpha really quick, here would be -1, or hold on, 1, -1, close, comma, 2, 3. So you write the first matrix we multiply, and then you just write the second matrix. And it should be able to crunch this for you. All right, if I can write it as a matrix. So remember, double bracket each one of the rows written with commas between them, and close the double brackets. Make sure that when you see this, here I get -1, -1, 2, 3, 3, 0, 0, 4. That gives me this. And then here, this makes it really easy to switch because I just cut this out, paste it here, add this, that. And here, if I switch the order, we get